All right, so thanks everybody for joining. Hopefully, we'll get some more people jumping in. Um, we're gonna spend a little bit of time talking about some business case stuff. We're gonna go into the hows and things you need to be considering in your OpenShift clusters and stuff like that. With me today, just like last time, is Christian. Christian, introduce yourself, brother.
Yeah. Christian Trujillo here. Been with Red Hat for about 6 years, actually. I just got my email saying congratulations. It's been 6 years.
Ooh,
So yeah, that's what happens when you're having fun. You lose track of time. And so yeah, it's been great. So happy to
yeah, I
be here.
feel that. Yeah, I appreciate it, buddy. I'm at my, I think, I think June marks 11 years, which makes me feel
Oh,
like,
nice.
how long am I at one company for?
Yeah, no kidding.
Not that I'm hating. It just is what it is at this point. You know what I mean? And man, that makes me start to feel dated. So, um, okay, so for those of you that were on before, we had in our last time we talked about a bunch of different things from kind of virtualization stacks, what's the world people are coming from, conversation topics to have with your business. At the end of that, we summarized up with a handful of questions that we gave out to the team to kind of take away. We are going to make time at the end of all this to go over those questions to see if you guys have any input or answers that you guys have had from your team, because I know some people are returning from last time. And then we'll have some more questions for you guys to take and run with at the end of this one as well. So yeah, with that, let's jump right into it. So first of all, some of this is so just so you guys are aware, Christian and I come from similar worlds, but with different background and mindsets. Myself, I obviously you guys know that I've been using OpenShift for a really long time. So is Christian at this point. But I sit very much on the consulting delivery side of things. So I'm going to have a lot of input and perspective on what this looks like boots on the ground. Christian has some of that background as well, but he's working with customers in a bit of a different capacity. So, Christian, why don't you talk a little bit about that, and then we'll dig into some questions that I have for you, if that makes sense.
Yeah,
What's your
definitely.
role look like on a day to day basis?
Yeah. Right now I've been focusing a lot of on helping our partners be ready to be able to support our customers better. And then prior to that, I was really helping customers directly, right? And
Yeah,
and that is a different dynamic than what I was doing before, which was more on the delivery side. Being on the more strategic side now, where I'm talking to the customers, trying to understand their current environment, where they're at, where the technology sits right now and the plans they have for the future. And
yeah,
that is a very interesting dynamic because I've been on that side of myself as well. And I feel that sometimes when you're in the day to day, you tend to focus so much on the now, right? On resolving the problems that you have now, that sometimes it's hard to think about the future, right? How's that going to look like? And if the now is really preparing me for the future, right? So I
yeah.
think, as you mentioned on the previous webinar, we talked about the assess, right? And the whole process that goes with assessing your environment. And right now, in this the deploy section, it's gonna be very interesting to have those discussions today.
Yeah, sure, absolutely. So when you're approaching partners now, because obviously, like many partners have been working with OpenShift, they've delivered OpenShift. OpenShift vert's a new animal to them. As you're talking to partners, potential customers with partners, etc., I'm sure there are things that you've run into that are kind of like their own either challenges or concerns about some of the changes and how different this is. What are the things people are presenting to you during those kind of initial conversations? What are you experiencing?
It's great to learn the different stages they are all in, right? Because I think that modernization is a journey, right? And we need to understand that it takes time to really modernize. And we're talking about modernization of applications, but also modernization of infrastructure. I think sometimes when we think about modernization, we tend to really think more about the application side. And yes, OpenShift is fantastic for that because it allows the customers that are ready to modernize the applications to be in the container world. But there's also the piece of modernizing the infrastructure, which is also highly, highly important.
Right.
Traditionally, organizations have been, supporting these applications on a very, very traditional infrastructure. right? That's made out of physical servers, maybe virtual servers, but as they're looking at modernizing those as well, there's all these concerns that are, is my people ready for that? Like I mentioned, sometimes when you're on the day to day, the engineers tend to focus so much on solving the problems now that maybe they're not preparing themselves for what's coming in the future, right? And so I
Sure.
think partners like you come in and help with that enablement, help to paint a picture of what the future looks like. And so some of those questions is my people ready? Is my people ready for that modernization? Is my people ready to modernize the infrastructure? Is my environment ready for that modernization as well? Are the VMs that I have right now ready to be modernized, migrated? And so I think there's those concerns of the people of the migration, and those are the main questions that I see customers having.
So do you feel like if, from your perspective, when you're dealing with customers and partners, are the people that you're running into, is it kind of a mixed bag of like tinkerers? I mean, we run into some people that are like really interest bleeding edge. They might even be large companies, but like they just do things differently, if you know what I mean. They're willing to really get their hands dirty and like if it breaks, we keep on moving forward. Like how much do you think, or how much are you running into organizations, should I say, that are kind of set in their ways. They're highly programmatic, highly structured with how they do things, versus the groups of people that are more, I would say, willing to risk change and like for the benefit of what's coming on the other side of it. And with that like split, how does that change their approach, in your opinion, at least from the partner and the customer side from when you're dealing with them?
Yeah, it's really interesting because there's a lot of on the public sector, right? When you're looking at government entities and some of the government customers that we have, they tend to be a little more reserved and more conservative with their approach to modernization. They
Right.
tend to take a lot more time to be able to migrate workloads, to bring new infrastructure, new processes, right? Even that. It takes them a long time to do that. Whereas some of the more innovative, startups or companies that have been really even doing business for a long time, but that are ready to continue to provide better services to their customers are more willing to do that. You're going to see a differentiation between those who are listening to their customers. If they're listening to their customers, they're going to know that the customers are demanding new ways, new very innovative ways to interact with them. An example, artificial intelligence. That's one of them. And then I know this is not about artificial intelligence. We can have that discussion some other day.
Yeah, for
But
sure.
but that alone, I mean, it requires an infrastructure modernization to be able to support AI into their processes, right? And so if you don't have the right infrastructure that is modernized to be able to support those workloads, it won't be able to support that. And so those customers of ours that are listening to their customers and the demands of their customers, they tend to think more in the future, right? In the innovation type of approach
Sure.
because they want to provide that innovation to their customers as well. So
Right.
yeah.
So are you feeling like is it a 50-50 split? And this is like I'm asking because I'm curious about like what kind of slew. I'll just start with this. I'll give you an example of what kind of I bump into for my customers, and then I'll see if it's kind of the same for you. So for us, sometimes we walk into a customer and they're 100 years built. It's an old bank, right? And like they have massive amounts of change control, and trying anything new seems so scary that like the conversation almost stops before it begins about how do you adopt something new, because they're just like, let's work with what's tried and true. And then there's the other groups that are like, well, it's not even they're willing to risk anything, but they're like, failure is an accepted attitude because failure leads to success, if you know what I mean.
Yeah.
And so the adoption of something like OpenShift obviously changes in those two worlds, right? So do you feel like the partners you're working with today are working more hand in hand closely with the people that are running at it? Let's just do this thing, let's jump into it, or are they more leaning towards the kind of groups of people who are set in their ways and trying to almost not convince them, but coach them to being comfortable with the situation? Because ultimately, not only is this the future, but it's just kind of also setting the stage for how we're doing things, moving forward, if that makes sense.
Yeah, there's a lot of value in partnerships. There's a lot of value in working with partners like Shadowsoft because you guys know your customers. You guys have
Yeah.
become trusted advisors, right? So your customers come to you guys for advice on how to approach this modernization, this process.
Right.
So I think that there is a big difference between those customers who are trying to do it, doing things by themselves, and those who bring partners along, right?
Sure.
Partners like that have the experience, the expertise, that have gone through this before. They understand the processes, the challenges that come with something like a migration, right? And then walk them through this process.
Right.
A lot of value in not just strategizing how to do it properly, but also being there alongside, not just doing it for them, but also enabling them to do it themselves. Because I think when they become self-sufficient, when a customer becomes self-sufficient, they tend to really adopt the new process, the new ways of doing things, and now they bring the partner back in for continued modernization.
Right.
I have
So
seen also, a split between, I will say, not all of our customers are ready to modernize, right? And so I think there's a lot of customers that are probably hesitant to go and modernize something that they've been doing it for a long time. There's also the concerns of the engineers themselves, right? When you have engineers that have been working on a platform for a long time, maybe they're certified in that platform, maybe they're very comfortable with that platform. They
yeah,
become,
dig into that more. Dig into that.
you
So
know, it's
like,
yeah, go ahead.
is it creating obviously there's tension, but are you seeing those people that are traditionally pushing back? Are they look because like it's funny you bring up the AI thing. I think to the AI thing as like people are afraid of like how it changes.
Mm.
Not the day to days so much, but like how long term it's either going to make people lazy or people are going to be trained differently. But it's making people cognizantly aware that if I'm not looking at where's my opportunity to fit into this puzzle, they
Mm.
could get left behind type thing. So when I say that and thinking back on the engineers that you're talking about that are kind of like the Oracle DBAs, the
Mm-hmm.
VMware 20-year guys, right? And they're being approached with this kind of solution. Are they changing their attitude a little bit because they're seeing the forest through the trees that this is where things are going? Or are they still being apprehensive? And if so, what does that look like when you're helping partners for helping them overcome that?
I'll give you a perspective from my experience as a sysadmin when I was a sysadmin, right? And starting my career where I am now and where I want to go in the future, right?
Right.
I think as technologists, we know the field that we're in. We know that the field that we're in is always changing, is always evolving, is always modernizing. As such, we need to keep up with that, right? Now, sometimes we get comfortable in our jobs, right? Because we're comfortable with
Me.
doing things, right? And
Yeah.
that's great too, but I think I've seen some of these very experienced and seasoned engineers that have been working on things for a long time, being a little bit just overwhelmed by what's going on. And this is because, Derek, they felt they had a lot more time. They felt they had
Right.
time for this modernization,
Right.
and that eventually will happen, and it will take some time. So they will gradually take those steps towards it.
Right.
Recent acquisition is speeding that up for everybody, from the leadership perspective to the engineer. So now they're really thinking hard about, we have to modernize now. So that means my skills that I have been using for 20 years could potentially become obsolete in the future. So what do I do? What do I do? How do I get my skills up and running? And I'm sure we'll probably touch on this on the next episode that we're gonna have here on the enablement side. But this is a reality that's happening, right? With a lot of the engineers.
Well, it's funny because, like, when you say that, I think about the number of people that are apprehensive traditionally that are now like, there's two different juxtapositions. Like, hey, I'm traditionally apprehensive. I want to stay doing what I'm doing. I'm now put at a fork in the road.
Mm.
Businesses are like, we got to move. We have to consider this yada yada yada. But the engineers fall into one of three categories. Either I like change, give me it. Those
Mhm.
are usually, I wouldn't say more junior, but they're usually more youthful minded, right?
Right.
So they could be more junior, but they're more youthful minded. Then there's the two levels of apprehensive. Apprehensive one is, well, I'm out of here. I'm going to go to the company that doesn't want to move, right? And I think we're never going to be able to deal with that, right? Like that just
Sure.
is what it is, and they'll learn their lesson eventually. And then there's those that are, I'm not going anywhere, but like I'm approaching this like in a way where like I want to find a way around it. In fact, I ran into a customer recently that was trying to dodge a migration between two different APM platforms because they were so heavily ingrained in one. And their mentality around it was, how do I make the argument that this thing, we're so ingrained, there's no way we're going to move to the business that they don't actually have to deal with it. So, in
Mhm.
terms of thinking about, the engineers versus the business in this situation, right? How do you perceive this kind of going in the short term versus long term? Are you interacting with partners that are and customers that are kind of like, hey, we're having attrition because people are going to other companies or people are willing to adopt, but there's more friction and pushback? What does that look like on a daily basis for you?
Yeah, and there are two different interactions, and you hit it right in the head there. It's very true what you just said, and it is happening in many organizations. And what I do see is sometimes the mandates come from leadership. Sometimes leadership is the one making that decision and pushing not just the business but also the engineers forward in that thinking.
Right.
And because it's coming from top down, then they're like, we must do it. So
Right.
now as an engineer, now you're forced to have to learn this new way, these new processes, this new technology, right? And at the end of the day, they end up very happy, right? They end up very happy.
Right.
That's the push they needed to be able to push him to the other line and to the other side. And then they realized it wasn't as hard as I thought. It was actually fun to relearn these things
Right.
again and to get on this direction. So I've been seeing that a lot where leadership understands in order to stay relevant, in order to compete, in order to continue to be a company that stays modern, we have to, migrate to modern platforms and adopt
Yep.
modern processes. And so that comes from the top down. Excuse me. I
No,
have
you're good.
also seen where the engineers are so excited about this new way of doing things that are trying to figure out and strategize how do we bring it to leadership. And sometimes we see that too, where the leaders
Yeah, yeah,
are,
absolutely. For sure. Keep going. Yeah.
yeah, where the leaders are like, well, we've been doing it like this for a long time. It's working, it's stable. We're making profits. And then the engineers are trying to figure out how, because I know that if I bring this technology into our data center, we're gonna be a lot more efficient. We're gonna be able to deliver applications much faster. We're gonna be able
Right.
to do this a lot faster and a lot more efficient. But how do we tell this to leaders to where they understand and we get the budget and the support to be able to move forward? And
Yep.
that is where the partnership shines as well, because
Yeah.
then partners like you, Shadows of, that come in, they can have that conversation with them, can strategize, they can understand what's going on right now, and then we build a business case to bring it to leadership. So those
Yeah.
are the two main approaches that I've seen.
Yeah, so in that same vein, people are a lot of times comparing OCP Vert and VMware in an apples to apples kind of way. And we've talked about this a little bit in the last conversation that we had. But I think when they compare them in an apples to apples kind of way, it makes them gloss over
Mm,
either from the business or the engineer, right? Like they're like either this thing sucks, it's so different, I hate it.
mm,
Like it's so difficult. Why would they build it this way? And the reality is it's different is not hard. Different is just different, right? So, but there's things that end up getting glossed over. When you feel like you're trying to enable a partner to go have these conversations and you feel like things are getting glossed over, what do you think some of the benefits might be that people are missing out on as they get into this portion of like starting to deploy it and looking at it really underneath the hood and seeing like, well, this doesn't feel like VMware. What are the
mm.
things that maybe they should be perceiving that they might not be, in your opinion?
Yeah, that's really good. That's really good because I think it's a natural tendency to start comparing things apples to apples. Is it the same exact thing? Like, am I
Right.
able to do this over here? How am I gonna do this other thing on this other side? And I think if we go in that route, is a rabbit hole that is very hard to get out of because
Sure.
there's so many intricacies that are not gonna be compatible. Why? Because it's a different technology, right? I
Yep.
mean, there's one technology that has been traditional for a long time and that is almost getting obsolete, right? Because it has to evolve. And there's a new technology that came from the open source community that continues to innovate, right? The
Yeah.
containerized approach. And I think when you look at that, we look at that, the VMs are running almost like a container within a container platform, right?
Yep.
And so I think this is a completely new technology in a way that the approach of the VM. You still have the VM, you still have the operating system the same traditional way, but the underlying and the supporting infrastructure around it, it's modern now. So I think when customers tend to start comparing and want to see is it apples to apples, they lose sight of what's coming in the future, right? The visionaries will be able to see it, but those who maybe are more analytical may take a little bit of time to really rationalize and understand why we're doing this thing now and today.
Yeah, and I want to double click on the visionary thing, and this will probably be like my last thing that I'm curious about from your perspective, which is like in Red Hat, obviously the business unit that's building out OpenShift and OpenShift Vert, they have an idea of where the ship is going.
Mm,
What do you feel like is things that Red Hat, because like I'll just give an example right now. You see these little tools and technologies getting released that are like they're not like a secret, but they kind of are. Like they're not
mm,
being like marketed heavily. Like you see Scupper,
mm,
which is Red Hat Service Interconnect. It allows you to network clusters together, right? There's like a product like that that gets released. And then like when they came out with OpenShift GitOps, it was like a very like
mm,
quiet thing that came out. And then it's like, oh, now it's like heavily integrated in the product. Do they talk about internally for you guys what the vision is of the future for OpenShift and OpenShift Vert? Obviously, OpenStack has gotten like a lot of minimization. Rev got, commoditized and then knocked away, right? So obviously this is where Red Hat's going as like we're all eggs in this basket. And clearly things are so different that there almost must be a vision of something that they
mm,
want to do. Do they talk about that with you guys at all of like where they're trying to guide the ship, so to speak?
mm. So I'll give you my perspective. This is not
Yeah.
Pat's
No, no,
perspective.
no, no. Yeah, and
Okay,
that's what
so
I want. Yeah.
yeah, so I give you my perspective, and yeah, we talk about product, what's coming and things like that, but not necessarily like the full vision yet. But
Yeah, yeah.
from my perspective, from what I'm seeing, what I see currently on the market, what I see currently with our platform, I mean, we're building such a powerful platform, right? That started with hosting containers, right? And that was
Mhm.
already a completely radical change in how we were approaching workloads, right?
Yeah, for sure.
And now we created that platform. And then we started adding a lot of capabilities and features to that, right? With the virtualization piece. And now with AI, right? We have OpenShift AI in the mix as well. This platform is becoming a very powerful platform for innovation, right? So those who are
Sure.
ready to innovate faster, deliver faster, which is really what's going to be required in the future for customers, are going to have a platform like OpenShift. The beauty of OpenShift as well that I see is that yes, there are options out there. There is the cloud that's out there, but a lot of those options you have to build yourself. You have to
Sure.
bring the pieces, the bits and pieces together to be able to build a platform that will work for you. Whereas OpenShift is a full-fledged platform ready to go. What we have also done, we have partitioned it from the subscription side into do you just want virtualization? You can have OVE, OpenShift
Sure.
Virtualization Engine, where you can have just the virtualization piece if that's what you need, but you still have the platform that's ready for the future. Do you
Right.
want to add containers? Sure, you can upgrade to the container platform now. Oh, you want to add AI? Perfect. You can also add that to the platform. So it's becoming a platform that is gonna help innovate a lot faster. But the beauty of it all is with the same user experience. I don't have to go and learn AWS today, and tomorrow I have to learn Azure, and tomorrow, and then the other day I have to learn Google. So now all this learning that's different, and all these processes that I learned is different now from each of these platforms.
Yeah.
Learn OpenShift once. You can be on-prem, off-prem, or hybrid. It's the same user experience. Whether
Right.
you're a developer, whether you're a data scientist, whether you are an SA, right, a system administrator, systems engineer, managing the infrastructure, they're all collaborating. So it's also a platform that is bringing collaboration because
For
now all
sure.
of those teams are coming together into one place. They're collaborating, they're strategizing, and it's a much better way to go about innovation.
Love it. Let's switch gears and get into that practical implementation side of things. So that way we can really start talking about that, the deep how, if that makes
Yes,
sense.
I love it. I love it.
Um, so where do you want to start?
I think let me ask you a question because I know you have been very very good on the delivery side and you see that all over and over again here. I want to dive in a little more into the architecture, right? The
Sure.
architecture of OpenShift and OpenShift virtualization. how much hardware do you see? Like, how much hardware is it required for this? How is it actually architected? What can you tell me
Sure.
a little bit about the clusters?
Yeah, so if you're comparing it to VMware, it's really different. So VMware, you could literally run VMware on one node, and you could do that with OpenShift technically, but it would be for really pilot use cases in terms of OpenShift virtualization. Why? Obviously, there's no high availability, but two, it's you're cramming so much of that what I call cloud in a box
Mm,
into a single physical machine. VMware has a lot less going on underneath the hood for that kind of capability set. So it's probably more distinctly could operate in that kind of environment. To use OpenShift because again, it's a cloud, it's a software-defined data center. To use it effectively requires several different nodes. Now, for those who are used to using OpenShift, this isn't news, but for those who are not used to using OpenShift, we're talking normally three control plane nodes, which that's really the brains of the operation. That's what's running the etcd, which is going to store your configuration state data for the cluster. It's going to run the scheduler, the authentication API, etc. Now, you could stop with those three machines and put all the other components inside of those machines for OpenShift Vert and all the worker capabilities. You can do that. I would recommend that if you do that, that's really for, again, smaller use cases, piloting, proof of concepting, because you're essentially commingling the
mm,
API and all the different capability sets with your virtual machines and your workloads, which doesn't bode well from a high availability perspective. If you want to do an update to the environment for just for example, and you have to move a workload from one node to another, now you're down to two, and your API has also been shorted down to two. So usually what ends up happening is people work with normally at a minimum three control plane nodes and then three plus worker nodes for running your virtual machines. Um, you can additionally, and a lot of times we do recommend running in another additional three nodes that are separated out called infrastructure nodes. For your edification, for the audience, you don't pay licenses for, or I should say subscriptions for the control plane or the infra nodes. You're only paying subscriptions for your worker nodes. What's an infra node? It's stuff that's going to run all of the different software that Red Hat's going to provide an OpenShift that you scale across your environment. That's logging, it's monitoring, it's your OpenShift router, all the different components that make up the fundamentals of the cluster for how it updates and how it works are going to go in there. So when you ask the question, how much hardware, part of it depends on what design you're going to ultimately have. At bare minimum, you're going to have three physical nodes that you're going to run your systems. Idealistically, I would say you'd probably look more like 9+, three for control plane, three for infra, and then three for your worker nodes, with some other caveats being added for when you go do an actual installation, because bare metal is slightly different. We can talk about that ad nauseum though. Yeah, that's the best way I would describe it.
thank you. Yeah, that makes a lot of sense. You know, I remember as a sysadmin managing also storage, right? That was part of the cluster, and I know that OpenShift comes with the storage capabilities, but why would somebody want to use maybe a third party storage? Is that needed? What are the benefits from
Yeah.
using third party?
This is where things get a little interesting because um OpenShift originally or I should say Red Hat originally had its own product portfolio for the storage system of the cluster. Originally it was based on Gluster, then it switched to being Ceph and Rook based. That was under the umbrella of Red Hat ODF. That product has since been taken into the IBM ecosystem. You can still get it from Red Hat if you buy OpenShift Platform Plus. So, for those that are listening, there's multiple subscription variants that you can get. The topmost subscription, which is the most feature rich, is OpenShift Platform Plus, and that does come with a version of ODF with it. However, if you don't get that, most people will go, well, can I just hook it up to my storage array? And the question is, the statement or response to that is, it depends. If you have NetApp storage arrays, for example, you could potentially get away with an ONTAP CSI driver. So inside of OpenShift, there's container native storage, and there's drivers or plugins for different storage systems. We could use some of these, and some of them will support, again, depending on your storage array, the ability to do things like live migrations. They might be not as feature rich or whatever, but third party storage, when we usually talk about that, we're usually talking about software defined storage layers. And that's where ODF came into Ceph slash Rook. That's where one of our big partners, Pure with Portworx, comes into play. What that gives you is a lot more capability enrichment. And it also allows you to be kind of agnostic underneath the hood with what your underlying storage array is. Think of it for the equivalence of vSAN and VMware. Okay. What that's going to do for you is it's going to do replication of volumes locally inside the cluster. You can have Portworx straddle two clusters and then be replicating volumes across said clusters. There's kind of a whole different opportunity when it comes to high availability once you bring in a software defined storage layer that you wouldn't get otherwise, right? Um, and that begs the question then of ultimately when you're going to choose a software defined storage layer versus being able to pull in some kind of driver for your existing storage solution is going to holistically depend upon what hardware you have, what are your ultimate requirements, and will they work natively? Some things you expect to work just, hey, we're going to hook up a fiber channel disk to our OpenShift cluster and use that for our volumes. That's not going to work necessarily because OpenShift Vert requires the ability to do read write many against volumes inside of a cluster. They can be file system based, they can be block based, depending upon your storage solution. But there's a lot of nuances there, more or less. And we would have to work with you to figure out what works best for you.
I love the fact there are options, right? There are
Yeah,
options
yeah.
available, and as you guys work with the customers, you can strategize on the best option, the best route that a customer can have, whether it is using the existing storage with CSS drivers that are available through OpenShift, or using something different. So I love that.
Yeah.
When it comes to the other challenge that I was mentioning initially about the migration, right? That thought of migrating workloads, the migrating the VMs. Some of those VMs are easy to migrate. Some of those VMs are more challenging. What do you think is the best path, the best way to migrate VMs to get them moved, and what's supported?
Yeah, so there's what you can do depends upon where you're starting from. So if you are a VMware shop, if you're at like VMware 7 or VMware 8, there's the ability to live migrate VMs using a tool called OpenShift MTV or Migration Toolkit for Virtualization. I wouldn't use that at scale per se. I would use that for small instances of getting VMs running. There are some requirements about that though. For example, I just had this app with a customer recently. We're doing an OpenShift Vert pilot with a customer, and we have the cluster installed. We have Pure for with Portworx installed in the environment. Everything's good to go. The customer's other data center where all the VMs live is in another state, which is fine, except that the backbone to their network is only 40 megabits for
Oh,
uploading of data. So you can't move a VM that way. So someone's literally going to have to go export the VMs to OVF files and then bring them over, and then we'll have to
oh,
manually import them. So that's no fun. But you could manually import an OVF file, especially if it came from VMware. We could have it talk to Red Hat OpenStack dynamically, automatically. I believe there's a Hyper-V plugin. I can't remember exactly for that or not. But there's a couple of different options depending on where you're coming from. Now, outside of that, what I would also recommend is bringing Ansible usually into play. And the
mm,
reason for that is MTV is really meant for grabbing a couple VMs and moving them over. You could still use the MTV software stack to move all of your VMs, but you're going to want to do it in kind of like a rolling batch process kind of way, where you're like maybe 5 VMs now, maybe 10 VMs later. And part of that's going to depend also on when you have the availability to do so, right? Like sometimes you're using a VM and like there's people actively engaging with that machine. And you're like, okay, we're not going to move these right now. So you'll want to do it in intervals. Red Hat has actually released publicly their the jobs that they've already kind of made in Ansible. So if you have Ansible automation platform set up, you could stand up these jobs pretty easily, point it at your VMware cluster and say, I want to move these 4 VMs or these 10 VMs, and it'll do it in batch life cycles for you. It's pretty nice. It's pretty sophisticated, and it works right out of the box. So it gives you a lot of benefit in that regard. But yeah, those are the kind of the things to consider. And also, just for anyone who's wondering, you can move VMs only, well, not only, but in a warm type situation or a cold type situation. You can't do it completely hot. And what I mean by that is When a VM goes to move, in order for the migration to complete, at the last stage at least, the VM will need to be shut down. It could be running while the VM's on, but the only way the last bits will sync up is if the VMs are finally turned off at the end. So just bear that in mind when you're planning out your migration paths, that we're not going to be able to migrate the VMs while they're all still running in perpetuity.
That's good. I love the mention about Ansible because it definitely enhances those capabilities, right? And there's some
Yeah.
going to be some VMs that are going to be a little more intricate. Maybe they have multiple storage attached to it, or drives and such, or network connections, right? Which brings me to the question: how does network work within OpenShift virtualization?
Yeah.
And can I actually map VM of virtual machines that are already mapped? Can I remap them? Like, how does that work?
Yeah, so this actually kind of also goes back to the hardware question you asked before, which I didn't even think about saying, and I probably should have, but now we'll talk about it, so it's fine. Um, there's other pieces of hardware you're going to need. First of all, for the OpenShift cluster, you're going to need a load balancer, and you're going to need that. It can be an enterprise grade one. I would recommend it, an F5, a Citrix, something that allows you to actually, from an enterprise perspective, map traffic between the different individual nodes and particular API endpoints. You'll need a DNS server, and you'll need some other machines during setup as well. But as it relates to networking in terms of the hardware, first, you're going to need enough network adapters to support the different types of traffic. You're going to need, number one, either one or two binded network adapters just for the management interfaces for the host. That's where the majority of the OpenShift traffic is going to funnel through in terms of pods communicating with each other, hitting the API endpoints, etc. Then you're going to want another binded set of NICs for high availability reasons, obviously, for doing the storage portion of the conversation. So you want your storage to go over a dedicated pair of NICs just because it's going to run more efficiently that way and you're not going to run into traffic problems. So think about that. And then the last piece that we usually talk about there, I mean, there's really two other you could say. Some people do an additional pair of bounded NICs just for migrations.
Mm.
So like the MTV would work just over that specifically. You don't have to do that. That's really more if you're really trying to be highly efficient. But the last one, really more importantly, would be binded NICs for VLAN traffic. You asked the question, how does networking work in this world? How does virtual networks really get mapped? Stuff like that. And really everyone thinks about in VMware they have all their virtual networks that are piped over different VLANs. The way that that works in OpenShift is essentially you'll have a trunked NIC that all VLAN traffic goes over. Obviously, they should be an aggregated NIC that's bonded together. But effectively, when you go to move a VM, you're going to have the option to pick a network that you want it to land inside of. Out of
Mhm.
the box, OpenShift for containers, and remember the VMs are in containers as well, had its own software-defined networking layer. It's called OVN Kubernetes. What that does essentially is it allows the containers to be able to route to each other dynamically with changing IP addresses, DNS names, etc. When you bring a VM over, by default, it's going to go into that networking space. But a lot of times you don't want that. One of the the negatives of doing that is the OpenShift software-defined networking is kind of like a moat. And what I mean by that is traffic from outside of the cluster can't hit the IP addresses of those inside of the normal OpenShift network. They're natted away. So essentially everything has to get reverse proxy through an OpenShift router to hit those pods and containers.
Mhm.
Um, when it comes to the VM network interfaces, though, if you do have this set up, if you have a trunked bonded NIC for all VLAN traffic, you could actually dynamically create VLANs with certain IP address ranges inside of OpenShift. And then when you go to move the VM over, you can select one of those virtual networks instead, in which case, just like normal VMware or any other virtualization provider, the IP address will be publicly exposed. And they'll be able to maintain the IP addresses that they had inside of your other virtualization environment. So you're not having to do things like rewrite static IP address rules and stuff like that. Does that help?
It does. It does. And it's as you were talking about the different configurations there's a lot of similarities with how you would configure on the VMware side, right? Because you
Yeah.
definitely had different networks for different things, vMotion, the
Yeah, yeah.
traffic, all this stuff. So it's similar in that regard. So it shouldn't be too hard to really understand that on the new environment. There are some intricacies within OpenShift
Yep.
that makes it a lot more secure. But yes, it's a little bit of a different configuration needs to be done. That's
Yep.
really good. What brings me to managing, like managing the environment. How does that look like, within OpenShift virtualization?
Yeah, so um we talked about this briefly last time. So things are a little bit different. If you're on Terraform or something like that, you could use a Terraform provider for Kubernetes. Regardless, you're going to be rewriting all of your automation code. And I don't mean that in a negative way. I mean it in a positive way, especially if you're doing containers with it, because then they're all sharing the same tools as we talked about previously. But effectively, you can now do CI/CD around your containers and around your virtual machine releases. So OpenShift is OpenShift GitOps. OpenShift GitOps is the open source project Argo CD. How that effectively works is you have a Git repository that has the automated code definitions, either in Helm or a Kubernetes YAML saying, I want these resources created in this kind of way. So, like, I want these virtual machines to be built. I want them to use this operating system disk. I want them to have this much RAM, this much CPU. I want them to be exposed in this way. All the different configuration parameters, right? But it's low code in the sense that you don't have to tell OpenShift in Git
Mm,
how to run that stuff. You're just putting Kubernetes manifests or Helm inside of that repository. Argo will then be pointed at that repository and listen on it to go, if someone wants to create a new VM or if someone is updated that Git repository, I'm going to take all that code that I see in there and I'm going to apply it to the OpenShift cluster. The benefit for that is change control becomes very, very, very easy,
hmm
right? So now you don't have to worry about bringing in third party systems. How are we going to manage how network policy rules change, all these other things? What you could do is have a Git repository that's for, let's just call it the production Git repository. Obviously, you'd have different ones for different apps, but for now, we'll say you have a production Git repository. That Git repository represents, let's just say, all the VMs in your environment or a subset of the VMs, whatever. If someone wants to add a new VM or change a parameter about something, they would push code into a branched version of that repository or into a forked version of that repository, and they'd put a merge request or a pull request in. Someone would then go in and you're just using GitOps workflows at this point to approve of that change. You could review it, go, this looks fine. We have the quota for this. We have the storage for this. Yes, we agree. Approve, and OpenShift through Argo will auto provision it into the environment for you. So you're actually by proxy of integrating all this, allowing change control to become more a part of what you're doing for virtual machines and containers alike, which is real nice. That's thing number one. Now, thing number two is obviously more the day-to-day operational stuff. Many people in VMware, they live in the vSphere interface.
hmm
Um, all of those interface type consistencies, like from how you get into the OS from like a VNC console, how you view logs, how you view metrics, all of that stuff's available for you in the OpenShift UI that's web based. You also have a ton of different tooling because, again, remember, it's a software defined data center. You can manage your storage with quotas to make sure that people can only get so much in so much space. Everything's going to be a little bit different, right? But you're going to birth yourself the opportunity to really be able to develop a practice around how you essentially maintain every facet of a software defined data center in a change control kind of way.
Yeah, no, that's great, and I love it that the enhanced capabilities that now an admin is gonna get, even with CI/CD pipeline, which is something
Right.
that maybe they're, as admins are not used to using within the VMware, right? Running that type of infrastructure, the
Yep.
enhanced capabilities that you get with it, that you'll be able to get comfortable with as time goes by,
Sure.
and it'll be added to it.
Yep.
And just the installation piece of OpenShift, how does that look like? I'm sure you've installed a few clusters already. So
Yeah.
what can you tell me
One or two, just a handful, not a lot. Okay. So installation, it depends. Explaining this depends where you're coming from. If you're someone who's run OpenShift, I would explain it differently, but I'll explain it for those who don't, or haven't used OpenShift, as well as there is nuances for bare metal that are just different. So thing number one is there's three different types of installation type. It's called IPI or infrastructure provision installation. There's UPI or user provision or user provision installation, and then there's assisted installation. Now, which one you use depends on what your environment has available to you, as well as how much hardware you have. So, thing number one is the one that requires the least amount of hardware is the assisted install. And quite frankly, I usually recommend in bare metal environments the assisted install, and I'll go into the reasons for that. Now, years ago, IPI wasn't even available for bare metal. What IPI stands for, again, infrastructure provision installer, it's a CLI interface that talks to the infrastructure. So in the case of VMware or AWS or Azure, this makes a lot of sense. In fact, you don't even have to do a lot for those kind of environments. In most situations, you have one configuration YAML file that says, this is the IPs we're going to use, this is the number of machines we're going to use, this is the SSH key I want you to provide, etc. And it goes and talks to the infrastructure provider. You run one command and it builds it for you, right? Great. That's not the case in bare metal. At least it wasn't the case for a long time. Now, if you have IPMI based power for your pieces of hardware, the installer can talk to the IPMI interfaces to bootstrap the machines and get them online and running, which is great. Makes things a lot easier. However, the IPI and UPI installers right now require a handful of additional machines. Thing number one is all of this is based on Core OS, right? So Core OS essentially has to be bootstrapped on all the machines to begin with. So you install you either put a USB disk in, you put a CD in, whatever, you load the ISO somehow to get Core OS loaded. Once Core OS is loaded, there's nothing really on Core OS out of the box other than the ignition system. The ignition system is going to want you to have a configuration file that essentially tells it what role it's going to be inside of OpenShift, along with some additional configuration information, like if you wanted to tell it these are the NICs I want you to set up, this is the storage I want you to set up, etc. So in this kind of a situation, you need a web server that's going to host those configuration files. You need a bootstrap machine, which is responsible for jump starting essentially the whole process. And you need a provisioner machine, which is part of this entire process. And what its real purpose is for provisioning different parts of the cluster itself. In addition to that, like I mentioned before, you need a load balancer. That load balancer is going to say, the control plane nodes are here. This is where the API will live. The regular worker nodes are here. This is where the router will live. So what happens is if you use UPI or IPI, you have, let's say you have a 3-node cluster. You actually, at least during installation, need, let's think about this, the web server, load balancer, provisioner, bootstrap, and your 3 nodes. You actually need 7 machines in the beginning. Now, the load balancer might be an appliance, so we could arguably say 6 machines, right? Um, you don't need those in perpetuity. You don't need those in perpetuity. The load balancer will have to be there in perpetuity, but you don't need the other machines in perpetuity, but you would need them up front. They could be small machines. If you go assisted installer, though, what the assisted installer does is it makes one of the control plane nodes temporarily a provisioner. And it uses that box to spin up the other 2 control plane nodes and other machines. And when it gets far enough along, it transforms itself into a control plane node. So you need way less hardware during the process of installation. It's way more streamlined. It's also fairly easy to use and allows you to inject a lot of custom configurations. Like if you have interesting things about what MTU settings you want for your NICs and stuff like that. Like just stuff that OpenShift maybe won't need to consider out of the box, additional requirements. You can funnel that through the assisted installer. So going into that, that was a lot, but I would say if someone's going to approach this today and they're looking for what's the best way that's going to be the most seamless structure wise, I would say use the assisted installer, and there's great documentation on all 3.
Listen, I mean, this is a thing of beauty, guys. I mean, I wouldn't be able to do and explain what Derek just explained. I haven't been installing, OpenShift as many times as Derek has
Yeah,
been, but I think that's the value and the beauty of partners, right? That you guys have done it so many times, Derek. That you guys
yeah,
already know the process. You know it so well that you can just say it like this, without
yeah.
having to read the manual like I would have to, right?
Sure,
But
sure,
I
sure.
think this is the value, right, that you guys can bring to our customers as well. And
Yeah.
with that, there's different costs associated with this, and there's different
Yeah.
flavors. We've introduced something new as well, OVE. But how are the costs of the platforms are impacted by the different flavors of OpenShift?
Yeah, so I know we only have a few minutes left, so I'll try and be brief. There's a number of different offerings. There's OVE, OpenShift Virtualization Engine. There's OKE, OpenShift Kubernetes Engine. There's OCP, OpenShift Platform, and then there's OPP, OpenShift Platform Plus. The first three don't include storage, right? So you always take storage into secondary consideration. OVE, OKE, and OCP and OPP, they can all run virtualization. If you're trying to just run VMs, or even if you're going to do VMs in one cluster and then you're going to set up another cluster for OpenShift, what I would full OpenShift, what I would recommend is for your virtualization clusters using OVE, it's just OpenShift virtualization engine. It's still OpenShift, it runs VMs, but you're not going to be able to run containers inside of it. So if you're somebody that's looking for virtualization either as a portion of what you're doing, or you're looking at it as a slice of the pie, so to speak, of other things you might end up be doing. I would create or not create. I would look at doing OVE for a number of machines that's just for virtualization. I would set up if I was going to do OpenShift full blown, I'd go OpenShift for a different environment, and then I would link the two environments with Scupper, so that way the two can network and talk to each other. OpenShift Service Interconnect. That'll save you a ton of money. OVE in terms of OVE, OKE, OPP, etc. It goes up from the bottom and most expensive. So OVE is the cheapest and it is very affordable. OKE is moderately priced. OCP and OPP are obviously getting more feature rich, so there's a lot more to it at that point. But obviously, there's all reasons to look at this. Most customers will do a combination of OVE with like Portworx, and then OCP for other clusters. So just something to take into consideration.
Yeah, that's great. That's great.
So I know we're getting to a point now where we didn't get a chance really to talk about the homework questions. Last time we talked about what's your virtualization stack. This is what we sent you home with. Are you using containers today? How is your team organized and divided from different groups, and what type of workloads are virtualized today? Justin and Sean and Derek, did you guys have a chance to kind of go evaluate these things? And do you want feedback on what you've looked at, or do you feel good and confident about where you stand right now?
I mean, I went through and did just the cursory level of what I
Sure,
knew. I don't think we had time to go through and discuss amongst ourselves. I
sure,
don't know if Justin went through and looked, but as far as like automation, we are probably at the halfway point. We're using Ansible
yeah,
for some things. We're
sure,
not necessarily integrating everything with full GitOps in order
yeah,
to do Ansible with it.
right,
Backups are automated, you know, a lot of that stuff. DR, it's not automated. It's a manual, but it's intentionally manual for
yeah,
playing follow the leader from our database perspective.
makes sense.
Um, as far as what do we look like, a lot of containers. That's what
Yeah, that I
most of our
know.
builds are. Yeah,
Yeah, yeah,
but we do still have a lot of legacy, and that's part of the concern too. Is what are we going to do with all these VMs? And the scupper conversation that you talked to today does bring some more to think about because what we may do is we've talked about a split brained data center where we go through and we have VMs only, and that may be like what you just discussed is have
it's
that on
exactly
one
what you should
side
do. It's
and
exactly what you should
containers on
do.
another, and then scupper in the middle.
Scupper's really lightweight too. It's super lightweight and it takes like 10 minutes to install to get your two clusters talking to each other. They just have to be able to the API endpoints of one cluster has to be able to reach the API endpoint of another cluster.
Okay.
Not bidirectionally. Just one direction has to work and then they'll create a WebSocket tunnel between them.
Mhm. I mean,
So,
the rest of the homework going through and looking at virtualization, are we containerizing? Yes, we're doing a
yeah,
lot of
that I know.
that.
Yeah, yeah.
The databases, we're still pretty much going to stay hardcore on regular legacy databases like we do
Sure.
RDBMSs today.
Yeah.
But the interesting thing is, since last we talked, we are branching out onto the cloud side and starting to look at ROSA, like you had mentioned a little bit already in this call.
Yep.
Um, that one does intrigue me as far as simplicity. The cost is the big thing on me is I'm paying for AWS layer with Rosa on top of that to go through and do all the make it easy, make the nice look and
Yep.
feel like a shift that we're used to. what is that cost factor in between if I run it on-prem with my hardware, paying for the hardware side versus AWS with ROSA doing that?
It would probably be cheaper.
Okay.
Honestly. Yeah, I don't know
Okay.
how much cheaper, but it will probably be cheaper to run it on your own hardware. If you're going strictly from a cost angle, I mean, AWS hardware is expensive
Yeah. Yeah.
when it really boils. Now, I'll say this, you don't have to pay for the hardware for control plane nodes because they use hosted control planes underneath the hood. All of its pods that are aggregated in a larger master cluster that they own.
Yeah.
So,
Everything else, it's the typical, like we've talked before, pure storage for the doing all the actual network storage
yep,
aspects of things.
yep.
Um, I mean, last thoughts are I like the moat analogy. That was actually very good. The visual on that makes a lot of sense on the
Yeah,
clusters. And I think I have seen Derek actually do clusters in his sleep.
I have.
I believe
um,
it.
So, in terms of other things to think about, obviously for today, for like homework and whatnot, and like I would be thinking about probably the first thing is kind of what we already just talked about, Sean. If you were to go this route and you are a container shop, since you guys are the only ones here right now, how you would divide them up. I strongly recommend making an OpenShift vert cluster and then linking it with Scupper like we talked about, but really think about that. Think about the hardware you have available. If you're going to do the full network setup where like you're having live migrations go over a custom NIC, storage go over a custom NIC, etc., you're looking at 8 interfaces per piece of hardware, right? Four bonds essentially on your box. So just bear in mind for that. And then I would be looking heavily at what's your storage that you guys have. Um, what are you thinking you're going to end up using? Which I think you guys are a port workshop, right?
We are. We've
Yeah.
also got things like what you'd mentioned. Cohesity is another one. Thinking about Fort Knox, cohesity, things like that. How do we attach that between the
Yeah.
two different? We've already got the existing VMware plane where those are going to. How would that
Yeah,
work?
I'd have to think about that. I haven't run into that at all recently, so I'm not sure how to best answer that, but that's something that I would definitely look into as well. Things you should be made aware of is Portworx is actually going to start supporting read write many block volumes over fiber in their next release, which I think comes out in June. So you'll be able to do really high performance compute in the VMs inside of it. You can already do pretty high performance compute inside of VMs, but that'll push it to another level. Because everything else is kind of like workarounds with read write many file systems where they're doing magic caching underneath the ground and
Mhm.
then turning them into bind mounts to get them more performant and whatnot. So they work great, but it will be very advantageous once that comes out as well.
One quick question for both of
Yeah.
you, as far as on the ROSA side of things,
Hmm.
if you go through and you stand up the vert side and start pushing VMs, how much of a success rate have you seen from customers with it?
Not with ROSA. I haven't seen a customer do OpenShift vert with ROSA at all. What I've seen is customers do regular OpenShift on top of AWS bare metal,
Mhm.
and then run VMs on top of that. That's fine. It's
Okay.
the same as running it anywhere else. Now, obviously, because of the way storage works in the cloud, you would need something like Portworx over top of the nodes in order to be able to scale between AZs, the storage. But that would be the next big thing.
Okay.
So yeah. There's one other thing I was gonna say that you should think about question wise. No, I think those are the ones for you guys specifically. If I was gonna consider anything else, I would also be looking at if I'm you guys from your automation tool stack, how well is it gonna marry up? Which you guys already know. You're in OpenShift already, so you should be good.
Okay.
Well, everybody, it was great having you all. Thank you so much for joining and staying with us the extra 5 minutes that we went over. Ross, the next talk is going to be about enablement, correct?
Yes, that's correct. Really,
Yes.
how do we upskill, enable the team to be able to manage this new world?
Cool. And when's the date for that, Ross?
That one is June 5th.
Okay, cool. So with that, guys, it was great talking to everybody. Great having a conversation with you, Christian.
Me too.
And we will see you guys June 5th.